Okay, 6th grade. Before we start, just a couple things I want to say. For those of you that are absent, I know I can't talk, Matt. For those of you that are absent, the challenge exponent solutions are up on the board. This is number 1, the first number 2, and then the second number 2 is over here. So just keep that in mind when you're checking these. We already went through them, so please make sure you pause the video and check these. The second warm-up was page 18 in your notes. Okay, for everyone, this week, Thursday is your test, and I call it a test because even though it's only on lessons 4.5 to 4.7, there's a lot of exponent problems on it, okay? I decided that the challenge exponent problems will not be a part of the test, the crazy big ones. However, that's a good bonus. So you could see them, but it won't be like the normal problems. The exponents on your test will be very similar to the worksheet from your homework packet, page 59, which I will pass back to you later today so you can make corrections. So just make sure you remember, test is Thursday. As long as I feel better, I have to go to a math conference this Thursday, so I will not be here at all. I have to go to Avonworth High School for a conference. So I'll make sure that Wednesday we take care of any questions that you have, and I will make sure that your only homework Wednesday is to study. That way you don't have to ask me anything Thursday morning, okay, since I won't be here. So keep that in mind as we go through the week, and I will keep reminding you. You'll have a sub, yep. I typically go to these conferences every other month. I just haven't gone yet this year because I try to only go to the really important ones. I don't like missing school. So yeah, you'll have a sub. Same procedure as always. You just have a test that day, and you will not have any homework after it. So just FYI, I wanted to give you guys a heads up about that. Mary? Yeah, there'll be a bonus. Even though it's technically a quiz, I'm calling it a test because it's pretty much the same amount of points as a test. And yes, there will be a bonus on it. More you'll see on Thursday. Okay, so any other questions for the test Thursday? Okay. Any other questions or comments on these 3 problems? Okay, so our goal for today is to talk about scientific notation. Now, I know a lot of you, actually all of you have learned it. To me, there's only one part that ends up being a little bit more difficult, and we'll get to that at the end of the lesson today. Okay, you may have already seen it before anyways. Okay, so let's go over the second warm-up solutions, and then we'll get into scientific notation, which is the last lesson of this chapter. Okay, so 1, 2, and 3 are kind of weird because these problems are an introduction to scientific notation. Basically, they're asking you to write it in expanded form. In other words, they're asking you to find the product. So anyone want to take a guess as to what the answer is for number 1, Matt? Good job. What about number 2, Charles? Good job. What about number 3, Mary? Good job. Okay, anyone want to try to explain how do you use scientific notation for 1, 2, and 3 to go from the expanded form to scientific notation form? It's today's lesson. I just want to see what you guys know. Sean? Yep. 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 To the right or to the left? Very good job. Mary? Huh? Good. So since it's negative, you would move it to the left three spots. 1, 2, 3. Very good job. And then you'd fill the zeros in. Charles? You mean negative third? Yep. I'm going to show you that on the calculator in a couple minutes. So yes, the calculator has sometimes weird notation. Okay, Emma M, number 4. Good. So these ones you had to leave in exponential form. Alyssa, number 5. Okay, but don't leave your answer with negative exponents. Good. 1 over 10 to the 19th. Donatus, number 6. Good, 10 to the 13th. Okay, number 7, find the product or quotient, use positive exponents. Doug, number 9, or 7? Good job. I wonder where my 9 and 10 went. Okay, good. 1 over 7 squared. Number 8, Justin? Good job. Okay, not sure where my 9 and 10 went, but I'm just going to write them. Number 9, Matt? Good job. Number 10, Annalise? Good job. 3 to the 4th. Annalise? Okay, let me do 9 first. Okay, number 9, the problem was 7 to the negative 7th times 7 to the 5th. Step 1, move the negative exponent to the bottom. So 7 to the 5th over 7 to the 7th. And then subtract exponents. You get 7 to the negative 2nd, and then move it to the bottom. Okay? Okay. Okay, anyone explain that? How do we know when to put a 1? Alyssa, how do we know? Good. Whenever there's a negative exponent on top and there's nothing on the bottom, when you move this to the denominator of the fraction, there is still a 1 on top. So, Annalise, did you understand what Alyssa said and what I just said? So if there's a negative on top and a 1 on the bottom, you move this to the bottom, but you can't just move it to the bottom and not put a 1 on top. Yeah, that's not right because you have to move it to the bottom. You have to move it to the bottom of the fraction. So if you move it to the bottom, you still have a 1 in the numerator. Okay? Alyssa? Oh, yeah, definitely. That's a little shortcut. Oh, yeah, I'm fine with that. Anyone else? Okay, so you guys okay? All right, let's go to scientific notation. So before we start, besides what we just went over in the warm-up, what do you guys know about scientific notation? Justin, what do you know? Good, you have to put a decimal, so it's a number between 1 and 10. What else, Annalise? Yeah, it's a way of kind of condensing and nicely writing a really big or a really small number, one way or the other. You use these a lot in science class. If you haven't already, you will do so when you get to the junior high. Just when you're multiplying crazy numbers, it's a way of condensing and organizing really big or really small numbers. Charles, what else? Good, scientists use it. You're exactly right. Engineers use it. Scientists use it. Say that again? They do, but there are times where they'll have to use scientific notation for certain things. They are basic. Yep. Mary. Hold on. Yeah. Oh, yeah. Yeah. So it's just, your calculator also cannot handle all those zeros. You're exactly right. So for us, it's a pain to write huge numbers or really small numbers, but also the calculator cannot handle all that. So they have to also use scientific notation. Doug? Yep. 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 Okay, so here's what I want you guys to flip over to page 19 in your notes. Here's what I want you to write down for where it says using scientific notation. There's lines there. It says a number is written in scientific notation if it has the form C times 10 to the nth power, where C has to be greater than or equal to 1 or less than 10, and n has to be an integer. So I'll say that again, times. A number is written in scientific notation if it has the form C times 10 to the nth, where C is greater than or equal to 1 or less than 10, and n is an integer. So if n has to be an integer, which is this exponent, tell me something n could be that has to be an integer. Emma H. Good, 1. Charles, what else? Yes, 0. Mary, what else? Good, 15. What else, Annalise? Good. Okay, Doug? Good, -5. So any positive, negative number or 0 could be n. Okay, it has to be an integer. So if you need to like underline or circle and put an arrow to that, you can do that. Also, c, which we've talked about a lot, has to be greater than or equal to 1, okay, or less than 10. If it's more or less than those numbers, then we need to take care of that, which we will do today. Okay? Because there are some problems where they'll give you maybe like 12 times 10 to the something. We would have to change it to be 1.2. Alyssa? No. C has to be greater than or equal to 1 and or less than 10. So it cannot be 10. So basically it's between 1 and 9, and it can be 9. Mary? Correct, and it has to be an integer. Okay, so let's do an example. Actually, we're going to do 2 examples. I want to show you guys how to do it by hand, but also on the calculator. So let's start with an example in standard form, which is just a regular number, 725,000. Okay, so standard form is 725,000. So don't do anything yet with your calculator. I first want to ask you, if C has to be greater than or equal to 1 or less than 10, what decimal should we change this to make that true? Justin? Good. So the product form is going to be 7.25 times, because you want to change C so it's between 1, greater than or equal to 1, and less than 10. So what would it be times? 7.25 times what? No, don't give me 10 to the whatever. We're just doing product form, which means times 1,000, times 10,000, times, I won't give you too many other hints. Doug? Nope. Annalise? Nope. And you can check these on your calculator. I'm going to give you a hint once someone gets it. Adam? How did you get that, Adam? Yeah. So that's one way of explaining it. Anyone else know how to explain it? We changed this number to be 7.25. What's an easy way for you to know that for product form that it has to be times 100,000? Emma H? True. Yep. You'd have to move it over 5 times. So you know there would be 5 zeros. But also, guys, look, this is in the 100,000s place, or it's a number that's in the 100,000s. It's very hard to say that. So since this is 100,000 something, it's 725,000, you know it still has to be in the same form. Also, let's take our calculator. Let me show you a couple options here. You could take 7.25, which is what we just wrote down, times 100,000. So let's just check and make sure that I'm not lying to you, which of course you guys know I would never do that. 1, 2. This calculator is very sensitive. 1, 2, 3, 4. Come on, I need another 0. Okay. I just want to make sure there's enough zeros in there. So another way to check it is, hey, use your calculator. Multiply them. Chapter 5 is when we're going to talk about fractions, dividing by hand, multiplying and dividing by decimals by hand. For now, just use your calculator. So product form you won't see as much, but it's something good to understand so you know how we're going from standard form to product form to scientific notation. Matt? Okay. Annalise? Hmm? Yep. Yep. Always. Scientific notation, C times 10 to the nth power. So scientific notation is always in the form C times 10 to the something power. So now I want you guys, we kind of already talked about this, how do we figure out what the exponent needs to be? How do we figure that out, Matt? That's on the calculator, not by hand. We wrote down, this is the form, C times 10 to the something. So, Donatus, what do you think the exponent needs to be? Okay, how did you get that? Okay, good. You could also take 7.25 to get back to standard form. Let's see how many times we have to move the decimal point. 1, 2, 3, 4, 5. If we put our zeros in, that gets us to 725,000. You could also look back at your 100,000, okay, and you could also think of it as the product form. From my perspective, I always go back to standard form to figure out what the exponent should be. If you're going from C, okay, so if you have C and it's getting to a bigger number, your exponent's going to be positive. You have to move it to the right 5 places. Charles? Yeah, let's type that one into the calculator. Let me show you guys. Yeah, but let's type in 7.25 times 10. So 7.25 times 10. Now, do you guys remember how to put an exponent? Remember from chapter 1, Adam? Good. Put the caret, put a 5. So caret is right here. Don't forget from chapter 1. Hit enter. Now, that one's not huge, so it will check it for us. When they're bigger or really small, you will see the E, which we will see today, just not on this one. Charles? You can change the mode and the settings. Yep. And I'm going to wait until tomorrow, I think, to show you guys that on the calculator, because I want you to also do them by hand. But the calculator is a great tool to check. You're exactly right, Charles. Annalise? Okay, so, yep. So if see this number here, which is C, when you try to get C back to standard form, if you're trying to make this bigger, you're going to be moving this to the right. So if you're moving the decimal point to the right, it's going to be positive because you're making it bigger. It's going to be negative if you're making it smaller. Okay? We're going to do a ton of examples. Okay, the second one I want to do, then we'll go on to the other examples, is 0.006. 0.006. Okay, so product form. What should the C value be for it to be correct scientific notation? What should the C value be for it to be correct scientific notation? Doug? Good. It should be 6. Greater than or equal to 1 or less than 10. Okay, times what? This should be easier now. For product form. Times what, Alyssa? Product form. Say that again? Yeah. So 0.001. You're exactly right. It's in the same form that the standard form number is in, but this is always just going to change to a 1. That last number or the first number, depending on what the number is. Correct. Exactly right. Okay, so let's go to our scientific notation. So we have 6 times 10 to the something. The form is always 6 times 10 to the nth power. Remember, C has to be greater than or equal to 1 or less than 10. The exponent has to be an integer. Sean. Good. 6 times 10 to the negative third. So here's a way to check it. If you rewrite your 6, which is your C, if you have a whole number, technically, where is the decimal point on the 6? You can't see it, but where is the decimal point? Justin? Yeah, the decimal point's right here. So if we want this number to get back to standard form, 1, 2, 3 is what we have here. If you put your zeros in, we can check that is exactly correct. So if your exponent's negative, you move it to the left. If it's positive, you move it to the right. If it's negative, it's a small number. If it's positive, it's a really big number. As Charles said, this is the only time that you can leave your answer with negative exponents because you're representing a really small number if there's a negative exponent. Okay, is everyone with me on that? Let me show you this one on the calculator. Let's just type in 6 times 10 to the negative third. So 6 times 10 caret to the negative third power. Make sure you use the negative right here. This is the negative symbol. And then hit enter. And it gives you 0.006, which was the standard form. Alyssa. Yep. You're allowed to use the calculator on the test. So it's a really good way to check. And again, I will show you on the next problem when the E comes into play. Annalise? What do you mean? There's a problem for it? What do you mean? Where? We're not on letter A yet. We're still in this box up here. We're writing these 2 examples on the box. Okay, yeah, no, that was supposed to all be in the box. Okay, now we're going to example 1. Okay, so example 1. Okay, this is kind of an interesting example. Anyone want to read this one for us? Adam?
The average distance from Earth is 141,600,000 miles.
Yep.
This number is
Okay, good. So where do we write the 141,600,000? What kind of number is that? In other words, where does that go? Mary, where does that go? Good. So everyone write that in standard form. Big number. Okay. Let's then go with, let's write this in product form. What should C be if it has to be greater than or equal to 1 and less than 10? Zach. Good. 1.416 times. So you should use my little tricks I gave you guys on the definition example. Emma H times what? Way wrong. You won't be at Mars if you only use that number that you gave me. You might be stuck in the middle of nowhere in the sky. Mary? Nope. Sean? Good. Sorry, I'm going over into the other box here. Okay, so why? How do we know, again, what number to multiply it by? Annalise, how do we always know? Good. It's always in the same, it's always the exact same number as Annalise said. This is a 1, the rest of them are zeros. You can double check it on your calculator, which we're not going to do on that one. We're going to do it on the scientific notation one on this one. But you can always check it on your calculator. Emma H, do you get it now? Okay. Emma M.
Well, you can also divide.
You definitely can. Good job. Yeah, as Emma just said, if you guys didn't hear her, you could also divide them, and that'll give you that it's 100 million. So if you divide this number by the decimal, that's another great way to check it. Okay, scientific notation, 1.416 times 10 to the something. So 1.416 times 10 to the something. Now, Zach, what do you think it is? Good. How did you get that? Good. So you're moving it over 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. If you fill the zeros in, it is the exact same number that we have in standard form. Why is the exponent positive? Sean, why is it positive?
Because the standard gets the multiplier. If it were to be negative, you would have moved to the left.
Good. Good. When it's positive, you're moving it to the right. Remember, if it's positive, it's going to be a really big number. If it's negative, it's going to be a really small number, and you move it to the left. This is easy, right? Because you guys have heard this before. Okay. Some of your faces I can't read today. All right, let's go to the second one. The diameter of a 1/4 ounce gold American Eagle coin is 0.022 meters. Write this number in scientific notation. Okay, so standard form is 0.022. I want you guys to do this one on your own. So go ahead and put it in product form and in scientific notation. We've done enough very similar to this. So go ahead and do this one on your own. Nope, it should be in the same form as this, 0.01. You just remember, you change all these other, this should be a 1, everything else is going to be zeros. Try this part needs fixed. Same with this one, be careful. This needs fixed. Okay, who would like to tell us what they got for product form? This one's a little tricky. Matt, what did you get? No. This one's tricky. Justin? Yep. So it's 2.2 times 0.01. If you check that on your calculator, you get the exact standard form. You can also divide, as Emma said, if you want to divide these numbers, it will give you 0.01. You could also think of it like we keep talking about. 0.0, this changes to a 1. Everything else changes to zeros, if you just want to do it mentally. Okay, Annalise? Nope, only the first number changes to 1. Everything else is 0. Think about this one. The only thing that was a 1 was this. Everything else was a 0. See? It's always the first number's a 1. Everything else is a 0. Yeah, you can't change. Keep the zeros if there are zeros. Change the first number. That's not 0, I should say, to a 1. Everything else is a 0. Okay, Emma? Huh? Yes. Yep. All right, scientific notation. 2.2, Zach, what did you have? Times 10 to the? Nope. Annalise? Good, to the negative second. Here's why. If we write 2.2 down, okay, on the bottom of your notes here, if you take the negative 2, if you move it over 1, 2, put a 0 in, 0.022 is the same thing as the standard form. Another way to do this is you could go back to standard form and count over 1, 2. Since you move it to the left 2 places, it's going to be negative 2. Zach, do you understand that? You sure? Did you just have too many zeros by accident? Okay. Emma? Yeah, if you want to, but that's not always going to be, yeah, because you could write that standard form as 0.022 instead of 0.022. You know what I mean? So I recommend not doing it that way, but it's up to you. Okay, example 2A and B are a little bit different. So let's now go, we're given scientific notation, and we want to put it into standard form. So we have 4.1 times 10 to the fourth, okay? Yep, positive. So for now, let's go from scientific notation to standard form first. Let's go from scientific notation to standard form first. So if it's 4.1 times 10 to the fourth power, Donatus, we're going to move the decimal to the right or to the left. The exponent's positive. Okay, to the right. 1, 2, 3, 4. Put your zeros in. What number goes with standard form? So what number is that? Adam? Good. So the standard form is 41,000. Is everyone with me on that? I know it's Monday. So if it's positive, move it to the right. What is the product form of that number? Alyssa? Awesome. 4.1 times 10,000. Getting easier, huh? Okay, let's go to letter B. Letter B, we have write 7.23 times 10 to the negative 6 in standard form. So let me write it out in scientific notation form first. We'll do product form last. So let's go from scientific notation to standard form. How do we write that in standard form? Charles, how do we write that in standard form? Okay, so how many times do I move the decimal point to the left? Good, it's negative. Move it to the left 6 times. 1, 2, 3, 4, 5, 6. Fill in your zeros. As Charles said, there's a lot of them. That's a 0. So 0.00000, 7, 2, 3. I just want to make sure I counted right. So there's 5. Yep, there's 5 zeros. Mine are a little smushed together, but there's 5 of them. Exponent's negative. You move the decimal to the left. Okay, what is the product form? What is the product form, Sean? Okay, how many zeros do you have? You had too many. Nope. 5. Okay, who can tell us why do you have 5? Why 5 zeros, Annalise? Yep. 1, 2, 3, 4, 5, 1. And then also, Sean, if you check on your calculator, it's not going to be right, so. Oh, yeah, not that. Don't do that. Okay, let's type this one in on our calculator. So 7.23 times 10 to the negative 6th power. Hit enter. So here's what Charles brought up. When you get an E, okay, the E is your calculator's form and way of telling you that it's times 10 to the something power. So the E on the calculator means times 10. Correct. So it's not very helpful is my point. There are times when you can't use your calculator to necessarily to check the standard form of when you write it all out because it cannot all fit on your calculator. You know what I mean? But if you type this number in, you could check that one because it will give you the scientific notation of it. And if we type this one in, let me see what happens. I can't remember if it changes it or not. 1, 2, 3, 4, 5. Does it change it or no? 7, 2, 3. Hit enter. Oh yeah, there's a good way to do it. You could type in the standard form. I wasn't sure if it did that. And it will actually check it for you. It's kind of cool, huh? Emma. Yes. Yeah. So, Sean or anyone else, if you accidentally have too many zeros, calculator's a great way to check it. I still want you guys to do it by hand, but use your calculator as a way to check. Okay? Okay, so I don't have time to get to the hard ones, which I'm not happy about, but that's okay. All right, so we'll do the hard ones tomorrow. Your test is still Thursday. Let me explain your homework. Okay, so I'm going to pass out your exponent worksheet. You have page 59 corrections, which I'll get to you in a couple minutes. Okay, only if you missed some of the problems, you need to correct them on another sheet of paper. Second assignment is practice 4.7, which is scientific notation. I didn't get to the harder ones, so we can't do all of them. I want you to do numbers 1 through 17. 17 is going to be like a challenge problem, but I want you to try it. Okay, hold on. Before you guys get packed up, let me pass back your page that needs corrections. Well, no, everyone's getting them back. If you missed some, then you need to correct them. Mary, can you give that to Sean, please? Go ahead, Mary. Okay, so let me explain this one more time. The paper that I'm just giving back to you, if you missed any, you need to make corrections as part of your homework. Please make your corrections on another sheet of paper and then staple it or put it back on top so you can give me the original back tomorrow so I can regrade it. And then also scientific notation, just 1 through 17, okay? I'll do the harder part and the multiplying tomorrow. I'm glad we at least got the big idea laid out. Okay, use your calculator to check it if you want. Doug? Yeah, because it's homework, just like I always do. Yep. Okay, anyone else? Any other questions? 2 assignments. Donatus, you got it? Okay, go ahead and get